Hey guys, in this video we are going to review one-step equations. Now before we do one-step equations, let's go over the operations. That's basically the math that's happening. So there's four operations: addition, subtraction, multiplication, and division. All you have to do in solving an equation is simply the opposite operation, whatever that is. And in a one-step equation, the order that you do them doesn't matter because you only do one. So let's look at our first example. We have x plus 3 equals 9. When we're talking about the operation, we mean what's being done to whatever you're trying to isolate, which is usually the variable, and in many cases, the letter x. So what happens is, I need to take a look at x and what we're doing to it. Well, here I am adding 3 to x. I want to cancel that out by doing the opposite operation. Well, the opposite of addition is subtraction. So to get x by itself, in other words, get rid of this plus 3, I'm going to do the opposite to both sides. What I like to do in solving an equation, I put a line down the middle to help me kind of see what the both or two sides are of my equation. So if I'm adding 3 and I need to get rid of it, the opposite would be to subtract 3. Well, positive 3 and negative 3 make 0. So x is alone. However, in an equation, to keep it balanced, I have to do the same thing to both sides. So if I subtract 3 on this side, when I cross the line, I also have to subtract 3. Now I can't just draw a line here because 9 minus 3 doesn't cancel out, doesn't make 0 like it did on this side. So this is when, we have to do a little bit of calculating. Well, 9 minus 3 is 6. Since this is gone, all I can do is bring down x. And so I'm left with x is equal to 6. And that would be me solving a one-step equation. So now let's look at subtraction. X minus 3 equals 9. I'm going to draw that bar down the middle. If subtraction is the opposite of addition, then that would mean addition must be the opposite of subtraction. So if here I am subtracting 3 from x, I need to add or do the opposite. And as a quick shortcut, since we know we have to do it to both sides, I'm just going to go ahead and write it twice, once on each side of the line, just so I remember. Again, negative 3 and positive 3, they're gone. They make a 0. So I'm left with just that x that I can bring down. On this side, now I have to take the 9 that was originally there and add the 3 that I just put. 9 plus 3 gets us 12, so x is equal to 12. These are the easier ones. Now let's take a look at the next level of one-step equations, multiplying and dividing. In this case, what am I doing to x? I am multiplying it by 3. When a number and a variable are right next to each other, that signifies multiplication. Sometimes you may also see it written with parentheses, but that's a little less common. So for now, we're just going to write it the more common way. And that is a number and a variable right next to each other. So I'm going to start by putting my bar. If they're multiplying, right, I am multiplying 3 to the x. To get rid of that 3, I need to do the opposite, which is divide. 3 divided by 3 is 1. And this is where things get weird, because I crossed it out here when it was a 0, but I'm also crossing it out when it's a 1. But why can't I just write a 1? You totally can. Sometimes you'll see people do something like this, because it makes them feel a little better. However, you're going to quickly learn that we don't normally write the 1 in front of the variable because multiplying by 1 doesn't do anything to our operation, right? Everything stays the same. So it's kind of redundant, and if you're like me and you don't like extra work, that's extra work. So why write it? However, if it makes you understand what's happening better, that's totally fine. This is not 0 like it was up here. They are different, right? Here we were adding and subtracting. Here I'm dividing. I'm doing something different. But I don't write that 1 because it's not doing anything to the equation. Now, if I divide on this side by 3, just like we did up here, I have to copy that to the other side of my line. Well, 9 divided by 3 is 3, so x must be equal to 3. Now our last one. This is the one that trips people up the most. We know that it looks like a fraction, and immediately your brain goes, fraction's scary. No, we can't think like that. We have to think about which operation is happening. Well, we did addition, we did subtraction, we did multiplication. The only thing left is division. A fraction is really just division. That's all it is. Fun fact, that's why your division symbol looks like this. those dots are placeholders for numbers. So a division symbol is literally a fraction. So don't be scared of a fraction. It's just division written personally in a more concise way. It looks a little nicer, takes up less space on the paper. So right now, what are we doing to x? We are dividing it by 3. Well, if division is the opposite of multiplication, then multiplication must be the opposite of division. So what we're going to go ahead and do is multiply both sides by 3. When we do this, we normally just put a dot in the number we're multiplying by, and they essentially cancel each other out the same way they did here. Right? I have the same number, top and bottom. Some people sometimes write it this way, and they multiply across like when you first learned how to do fractions, because it makes it visually easier to understand that they don't just cross out. What's happening is that long ways, we have 3x, multiply across over 3, and what do you know? This becomes an x just like it did over here. But again, to save you some time, and what you'll most likely see in the future, is just this. So we're left with x. Now we know we have to do the same thing to both sides, so I'm going to multiply that 9 by 3. And I get that x is equal to 27. And those are all the possibilities you may have when you have a one-step equation.